Hey, what's going on, guys? CodeMacaKings here. In this video we're gonna start implementing our evaluation function. So as far as the perf test has been successfully passed in the last video, this means that from now on there is nothing to stop us from writing a search logic, basically. So our main NingaMax search function followed by the quiescent search. But the problem is that at the very end we really need to return the evaluation score for current given position, for every single given position that we're walking through within our search. So you can observe search just like a perf. The only difference would be that it won't be really walking through all the possible moves there, but instead it would use something known as the alpha beta pruning. So even though I'm not going to be diving deeply into explanation like how that works, well, at least in this series, well, maybe I will make some separate videos on that, but still it's absolutely essential for basically whatever search function to return an evaluation score. So that's the exact way of how one can actually distinguish between the moves, between a good move, a better move, a worse move within a given position. So you saw like it generates really all the possible, all the available, all the legal moves within the position, and it's not enough. We actually need to make a move, and in order to make a move we need to pick the one that returns the highest score. So the evaluation function is actually the exact function that would be that would allow us to return that score, that it would allow us to evaluate the position. And evaluation itself is really has really a wide range of opportunities, and modern world-class chess engines has really lots of features in there. But we would implement two very basic features. Those we can't actually do much without. So we would be evaluating material and the positional score. So evaluating material is quite pretty self-explanatory, because we just need to calculate the number of pieces on board, and if we then evaluate every piece. So for every white piece we would be adding the score, for every black piece we would be subtracting the score, and at the very end we'll have like the difference, so who is better, who is worth it. So say white is pawn up, then it would have a slightly better score compared to black. And but this is good, but this is not enough, because if we have material only evaluation, our chess engine will have no idea like where to put its pieces. So the second thing to consider would be to implement the positional scores as well, and this would be covered within the next video. So I just wanted to provide this little guideline regarding what in particular we're supposed to be doing within the next few videos, and let's actually start implementing our evaluating material scores. So I just want to create one more array here, yeah, well, let's say below where to put it. Well, I just need to reference my encoding basically. So well, let's put this right over in here. So material score, and I want to create the integer, the array of integers, and let's call this simply material score. And this would be the length of this array would be just exactly the same like we have here in our ASCII pieces or Unicode pieces, so or as we have here. So well, no, it's not like here, but like here. So let's count them using this Unicode pieces. So 1 2 3 4 5 6 7 8 11 12 13 14 15. So 15 elements here. So we got 1 2 3 4 5. So oh my god, what have I done? It's time to learn to count. Okay, So 1, 2, 3, 4, 5, 6 plus 6, 12, and plus one more, we'll have 13. Okay, so I guess 13 would be just enough here. And just like we used doing this then before, it's quite pretty simple. So we would be using, we would be looping over the board pieces, or over the board squares. Then we would be picking up a piece on a target given square, and use the piece code as an index to index this material score array. So just literally the same like we did when we were printing the board. We just use the piece array, the piece index, in order to index this string, because it's array as well, and just to pick up some character in return. And here, instead of picking up some character in return, we would have been picking up some score. So the empty square should return 0, so we're not taking this into account at all. And then we go for both white and black pieces. So probably I should mention one little rule regarding some, you know, like some basic rules of how to evaluate positions, basically. So I just want to let's probably take this Unicode symbols to represent how valuable these pieces are. So the pawn is known as the minimal kind of constant of the evaluation score, and it equals. It doesn't really matter how what in particular kind of integers we take in order to represent this, but it's quite a good idea to say like that pawn is worth 100 points. And then if we say then we can take all the other pieces. So just want to copy the knight here, and then the bishop. Sorry, what have I done? Copy, and the rook. Okay. Then we pick up the queen and the king. Color doesn't really matter that much, because obviously that's very important to have same score for black pawn or for white pawn. Otherwise it would consider like black pawns to be more valuable than white pawns, and engine would return nonsense instead of instead of a good position. So knights usually evaluated as either 300s or even 350. So let me just try and explain you what does this mean. So if I just grab my pawn again, so we can say, so well, pawn is worth 1 pawn, but probably I can put the equal signs here, and knight is worth for about 3 pawns, up to 3 pawns, and bishop usually equals for 350. So it's kind of like pawn. So well, here I can say, let's say actually pawn multiplied by 3. Okay, and here we got this pawn multiplied by 3 and plus pawn multiplied by 0.5, so just half a pawn. That's kind of it. So if it was kind of 4 pawns, it would be 350, but we just got this 50, so just half of pawn. So this is the way how to evaluate this. And a rook is usually treated to be, oh my god, I don't really remember how many. I've been copy pasting these values from my engines from one to another, so let me just try to remember this. So if we get yeah, probably 5 pawns, yes, so 500s, and we can say just pawn, yeah, pawn multiplied by 5. Yeah, this is it. And the queen is worth 10 pawns actually, so well, I can just make it like this. So pawn multiplied by 10. Okay, and king is actually not about to be evaluated as a piece to capture, but it's still quite pretty useful to give this like really big evaluation score like this, 10,000, so to avoid engine trying to exchange king in order to get a better position, because it's this might happen from time to time if something has gone extremely wrong. So, and this would be, I guess, pawn multiplied by 100. So if 100 to be multiplied by 100, oh my god, I need to learn how to count. Okay, just hold on a sec. 100 and 100, we get is this 10,000? Yeah, oh my god. Yeah, multiplied by 100. Okay, yeah, sorry guys. Yeah, I'm really bad in math. I've been talking about this really numerous times already. Yeah, but this is not the reason not to do chess programming, obviously. So this is kind of it, and now we need to associate our indexes, the elements of the material score array with specific indexes for our pieces. So you remember, like we have pawn being encoded as 1, this knight is 2, 3, 4, 5, 6, and then black pieces go like 7, 8, and so on. So we agree to use positive score for white pieces and negative score for black pieces. So here is the evaluation for a pawn, and then we go for, well, I could have actually give even more extended explanation here. So I could have say like white pawn like this, and then let's say we have this 100, so like this, yeah. So sorry, it's not a white pawn, it's an empty square are not taken into account, empty square obviously. So here we have the score for the white pawn, empty square score, okay, white pawn score. Then we go for white knight score, and you know, like already there is a big, oh my god, there is a big opportunity to play around with this scores in order to alter the behavior of the chess program. Well, we can't alter it yet because it's not actually playing chess at the moment, but when it will, changing this material score might be very interesting. Say if we set knight score equal to the bishop score, in this case he won't be exchanging, say, knight for a bishop, and if in this case he would be trying to keep the bishops on board, because bishops are considered to be more valuable. So this already can give a significant impact on the style of play, so just to bear that in mind. Okay, white pawn score, and then we go for white bishop score, white bishop score, and then we go for white rook score. Okay, and you might wonder that it's not essential to give such a detailed commentaries, but you know, like when I just started with the chess programming, even these trivial things were not really that trivial for me personally. So here we got white queen score, and yeah, I just need to say, so this is the material score. Well, I guess the piece name already kind of assumes that implicitly. And here we got white king score. Okay, and now we just go for black pieces. So here we just need literally the same, but with minuses. Okay, so we're very simple. So just adding the minuses here like this, and just don't forget to change this to black within the commentaries. So black pawn, black knight, black bishop, black rook, black queen, and black king. So this is it, quite pretty self-explanatory. Okay, so I guess we can already kind of start implementing our evaluation function. I'm just wondering, yeah, it has to be before the search to avoid that weird implicit declaration warning in C. Okay, so let's scroll down here, and so what do we have from the previous part? Perf test. Okay, so I don't really want this perf test for a while. Okay, so we got this perf test as the very last part. Yeah, probably I will just simply start defining our evaluate position function here. So position evaluation, or evaluation of the position. Okay, and let's create, so this would be the integer. It's important because this function would be returning an integer value, the score itself, which is really important. So let's call this evaluate, and or maybe evaluate position, or should I? Oh, let's call this evaluate position. I'm not yet sure whether it's supposed to be taking any arguments. Yeah, we'll see later on. So okay, so the very first thing to consider, anyway, the very first thing to consider is just to loop over all the board pieces, and obviously already this will decrease the performance slightly, and it's not really that great. That's the reason why in kind of stronger chess engine people use thing that is called piece lists, and piece lists is some sort of a data structure allowing us to instantly look up the pieces, the squares associated with the pieces. This is something like we do with the king square. So you remember, like, we don't search for a king square, we just look up for a king square. So something similar for all the pieces. But as far as that complicates the move generator significantly, I took a decision to drop piece lists just for simplicity. And obviously one day I'm going to implement them and to explain how they work, and so on and so on. Okay, so we need to loop over board squares, obviously, and I can say for in square equals to 0, square is less than 128, as always, as usual, and square plus plus to increment the square every next iteration. And now we need to make sure square is on board, so our expression, so if not, square bitwise ended with a hexadecimal 88. In this case we do all this stuff. Okay, probably we also need to initialize score variables, so in score would be equal to 0, save, and what now we need to define what we're supposed to be returning from this, evaluate position function. So I can say if not side, so if side is equal to white, other words, so let's give commentary. So or maybe just provide them, or okay, let's say return score, return position score, and here probably I don't even need this parenthesis, or well, we'll see. So we need to, oh my god, what have I done? Not here. So this so if it's white, we need to return score, and if it's black, yes, we don't need this definitely. So white score, or score for whites, and else we want to return score for black, and just return minus score. So this is needed, assuming that we're supposed to be using Nigimax search, and just this would be covered within the next videos, obviously. And I'm just wondering, yeah, probably let me just try to rewrite this. So I guess this should be enough to say like not side and return score, otherwise return minus score. Yeah, and here I just say return score, return positive score for white and negative for black. Okay, and now let's evaluate our material. So material evaluation, and okay, so I guess we also need to initialize our piece. I guess it would be nice. So initialize piece. So let's say int piece equals board indexed by the square. Okay, and as far as we do have the zero evaluation for our empty squares, we can not say like if piece is not equal to 0, so we can simply reference, so we can say score plus equals and material score array indexed by the piece. And this should be it basically. So let's try to open the terminal in the current working directory, and by typing make I want to compile this, and if it compiles it will produce the binary executable called chess hexadecimal 88, and I'll try to run that. Okay, expected expression before return. I'm sorry, it's not done like this. Sorry, it's done slightly different, so I can say return. And now depending on the site, so if not site, oh my god, not site, in this case we want to return score, and otherwise minus score. Yeah. Okay, yeah, I haven't been practicing ternary operator recently for quite a bit of time, that's the reason. So, I guess now this should be okay. So if I got the semicolon, okay. Yeah, now it seems to be working. Okay, so I'm just wondering where exactly am I supposed to be printing the score. So probably after this board information. So I'm wondering if I just call my evaluation function. But hold on a sec, why did I put my evaluation function within in between between of two perfs? So it's not a good idea. Let me just bring this down here. I have no idea why did I put it there. So definitely not the right place for it. So let's try to evaluate position, and I just call this evaluate position, and I also, so tricky position, as far as we are evaluating now, like the on material only, it's better to use this, to make use of the starting position. So just define here start position. So let's have a look. Yeah, and also we don't yeah, we can print this. Yeah, so let's say score equals like this, and now we can just print our score. So simply say score and decimal value, and followed by the new line and the score here. So it should give us a 0. Okay, score is undeclared. Yeah, integer, obviously. Yeah, score equals to 0, which is good because we have all the equality on material. And now let me just try to get rid of some pieces on the board and see whether the evaluation is going to be changing or not. So in order to do this, I just want to grab my initial starting position here and paste this as an argument to the parseFEN, save, and let me just try to get rid of one pawn, of one white pawn. So in theory, now the score should be minus 100, because if we have a look, at our scores, this here, so there would be one white pawn less. So yeah, so there should be minus 100. So let's see. Yeah, minus 100, perfect. So if we take, say, let's put it back. Okay, now let's get rid of white knight, and now it should be minus 300. Save. Yeah, perfect. And if we just try to try the same with some black pieces, so let's get rid of the black knight, it should be plus 100 now. Okay, and if additionally to this we'll get rid of white pawn, this should be plus 400, because 300 for a knight and 100 for a pawn. Yeah, so this is it. You see, like, we have this material in balance, and the score represents this appropriately, respectively. So yeah, it seems like the material evaluation is about to be just fine. So if I did miss something, I'll definitely fix this next video. Anyway, so the next thing to consider would be to create the positional score array. I'm not yet sure whether I'm supposed to be providing the only array for that purpose, or maybe separate arrays for different piece types. Probably that doesn't really make much sense, so we'll see basically. And yeah, and basically that we will end the evaluation at that point, and we'll be able to move on, move to the search, to implementing some search logic there. Well, this is it from my side, guys. Thanks for watching. I hope you learned something interesting out of this tutorial. So until the next time, and take care.